Welcome to my YouTube channel, IB Chemistry with EAF, and today I'm going to talk about structure 1.1 as well, reactivity 1.1. We're going to do some equations to help us to consolidate all our knowledge that we have gained from the previous video of how to calculate Q, delta H, and today we're also going to learn how to do percentage error. So as I already mentioned, we're going to talk about Q, and we're going to use the equation Q equals MC delta T. To find delta H, we're going to do negative Q over N. And lastly, we're also going to do percentage error, where we have the measured value minus the accepted value divided by the accepted value multiplied by 100. Okay, so let's begin. So we're going to do calculating delta H. For that, we need the Q equals MC delta T and delta H equals negative Q over N. And remember, if it's negative delta H, it's exothermic, and if it's positive delta H, that means it's endothermic. Okay, so let's begin with our first question. 0.0125 mole of glucose undergoes combustion and raises the temperature of 200 grams of water by 34 Celsius. Calculate delta H and draw an energy level diagram. Okay, so let's break down the question. So we can clearly see we have 200 grams of water. So M, let me actually highlight it. M is going to be 200. Then C, the specific heat capacity, we know it's water, and in the booklet, water is 4.18. So the heat capacity of water is 4.18. Let me highlight water. And lastly, temperature. And as we can see in this whole reaction that the glucose undergoes, the temperature is 34 Celsius. So 34 Celsius. What we also later need is the amount of moles, which is 0.0125. Okay, so now let's calculate Q. To calculate Q, let's use purple. Q equals 200 times 4.18 times 34. This will give us Q. So Q equals 28,424 joules. This is joules. Okay, so now if you want to turn it in kilojoules, we divide by 1,000. So Q equals 28.424 kilojoules. But to find delta H, we would do delta H equals negative Q over N. So we have our Q, and we can put it directly into, let's do negative 28,424, and we have the number of moles, which is 0.0125 mole. Let's write it down. 0.0125 mole. And that will give us negative 273,920 joules. Important, joules. But we want our answer in kilojoules, so we divide by 1,000. Therefore, delta H equals negative 273.92 kilojoules. Don't forget the units. Mole minus 1, mole minus 1. Okay, so the answer is delta H equals negative 2,273.92 kilojoules. So the question, we have answered half of the question. We have answered delta H. But the question is also asking us to draw an energy level diagram. To do that, we draw our first line. So what goes through is glucose. So we have C6H12O6 plus 6O2. And that we already know because delta H is negative, that means it's exothermic. So the reaction is going down. So let's bring it down to over here. Delta H equals negative 2273.92 mole minus 1. Always add the units. And then lastly, last step would be, that will give us 6CO2 plus 6H2O. Okay, so we can clearly see this is going down. That is our energy level diagram. Okay, next question. Let's rewrite this. So we have Q equals MC delta T. So we have M, Q, and delta T. We can also add N, and we can also add molar mass. Okay. So a 1.5 gram sample of potassium chloride is added to 35 milliliters of H2O in a styrofoam cup and stirred until dissolved. The temperature of the solution drops from 24.8 to 22.4. Assume the specific heat capacity, of the resulting solution is equal to those of the water, 4.18, and respectively, and assume that no heat is lost during the calorimeter itself, nor the surroundings. Okay, try to calculate delta H. Okay, so we can clearly see at the beginning, it gives us the specific heat capacity, 4.18. What we also know is the mass. So we have grams, but we also have, let's use a different color. We have 1.5 grams of KCl, and we also have 35 milliliters of H2O. Since we know it's water, therefore we use the 35. So 35. And delta T, to calculate that, we do the final temperature that we have calculated, which is gonna be, let's use purple, which is gonna be 22.44 minus the 24.88. So we will do 22.4 minus 24.8, which will give us negative 2.4. Okay, so now we have Q equals MC delta T. Let's now calculate it. So Q equals 35 times 4.18 times negative 2.4. So you put in the calculator, 35 times 4.18 times negative 2.4. That right there will give us negative 351.12. Okay, so now we have Q. So Q equals negative 351.12. Okay. And to find delta H, because we know the formula, delta H equals negative Q over N. And N is the number of moles. To find out the moles, we need to know the molar mass of potassium chloride. And to do that, we go to our periodic table and we're gonna check. So, but to calculate that, we're also gonna use mass over molar mass. So moles equals mass over molar mass. So we know that the mass of potassium chloride is 1.5. So we can for sure put 1.5. And the molar mass is 74.55. So that means we're gonna do 1.5 divided by 74.55, which will give us 0.02. So that right there is the amount of moles that we have. So we have Q, which is negative 351.12, and we also have the number of moles. Now to find delta H, we do delta H, I forgot to put the units, always put the units, joules, mole, -1. To do that, we do negative bracket, negative 351.12, close the bracket, over 0.02. And that would give us, divided by, it's gonna give us 17,450.66 joules, important joules. And to convert it into kilojoules, we divide by 1,000. So we get delta H equals 17.45066 kilojoules mole -1. And that is the answer. Okay, let's do one more example. Okay, in a coffee cup colorimeter, 1.8 grams of NH4NO3 is mixed with 74 milliliter of water at an initial temperature of 25 grams. After the dissolution of the salt, the final temperature of the calorimeter content is 23.707. Assuming the solution has a heat capacity of 4.1, calculate the heat change of the dissolution of NH4NO3. Calculate the enthalpy change for the... Okay, so what do we need to calculate? Delta H. Okay, and to do that, let's do our normal thing again. Q equals MC delta T. MC delta T, mass, molar mass, and then we can put a Q at the end as well. Okay, so what do we do first? We first try to find out the mass. This is a really tricky question because it says mix. If you mix it, right here, it says the word mix. If you mix it, it means we take our 1.8 grams and we add them to the amount of water. So we do, so M equals 1.8 plus 74, which will give us 75.8. That is our mass. If you mix it, it's like that. Okay, so M is 75.8. Our specific heat capacity is 4.18. So we do 4.18. Delta T, how we calculated with, we do delta T equals 23.07 minus 25. 0.07 minus 25, which will give us a negative 1.93. So delta T equals negative 1.93. Then our mass for our substance NH4NO3 is 1.8. So we write 1.8. Our molar mass of the ammonium nitrate is 80.04. Okay, so now we have all the values and all the components that we need to answer the question. So let's do it. So we do Q equals 75.8, 8 times 4.18 times negative 1.93. And that would give us 75.8 times 4.18 times negative 1.93. Negative 611.5. Okay, so now Q is negative 611.5. To find delta H, we also need the number of moles. And to calculate the number of moles, we do mass over molar mass. So we have a mass of, as I already mentioned, 1.8 divided by the molar mass of ammonium nitrate, which is 80.04. So we do 1.8 divided by 80.04. That will give us 0.022 to be exact. So we do, to find delta H, we do negative, we close the bracket, negative 611.5, we divide it by 0.022. So we do negative bracket, and that will give us 27,191.76. That is in joules. We can just write joules, mole minus 1. And to find it in kilojoules, we divide it by 1,000. So we have 27.19176 kilojoules, mole minus 1. Okay, and that right there is the answer. Okay, so now we have shown that we understand how to calculate delta H and how to as well calculate Q equals MQ, which is Q equals MC delta T, and delta H equals negative Q over MC. Okay, so now let's go to the percentage error. Okay, so we have, as I've mentioned earlier, how to calculate percentage error. We have our measured value, measured minus accepted, we bracket it, divided by accepted. And we multiply that by 100. So we get a percentage. Okay, so let's start with the easy one. Easy. Okay, a student reacts 5.0 grams of NaCO3 with HCl to produce CO2. To accept mass of NaCO3 for the reaction is, the accepted mass is 5 grams. Okay, how do we calculate the percentage error? So we have our measured, which is, okay, so we have measured, which is 5.02, and we have our accepted, which is 5.00. So we do 5.02 minus 5.00, we bracket it, divided by 5.00 times 100. So we do 5.02 minus 5.00 divided by 5 times 100, and that will give us 0.4%. So the percentage error is 0.4. Okay, good. Now let's go to the medium. Medium. Okay, so let's write our measured and accepted. Okay, so a student burns a sample of butane and measures 12.6 kilojoules of energy released. The accepted energy is negative 11.8 kilojoules. Calculate the percentage error. Okay, so we know that our measure one is negative 12.6, so negative 12.6 kilojoules, and the accepted one is negative 11.8. Negative 11.8 kilojoules, so I will give you another minute. So we do negative 12.6 minus negative 11, negative 11.8 divided by negative 11.8, and we multiply it by 100. So you put in the calculator, negative 12.6 minus negative 11.8 divided by negative 11.8 times 100 is going to give us 6.78%. So the percentage error is going to be 6.78. Okay, now let's try the hard one. So hard, we're gonna do, okay, measured and accepted. Okay, so we have, during the experiment, the pressure of gas is measured at negative 3.21 times 10 PA, while the accepted pressure is gonna be negative 3.3 times 10 to the power of 4 PA. Calculate the percentage error. Okay, so we know our measure one, which is gonna be negative 3.21 times 10 to the power of negative 4. And the accepted one is negative 3.30 times 10 to the power of negative 4. So we do negative 3.30 times 10 to the power of negative 4. And now we do the same thing. We put it there in our formula, which is this one, measured minus the accepted. Okay, so we do negative 3.21 times 10 to the power of 4 minus negative 3.30 times 10 to the power of 4, and then we close this bracket and close it again, divided by negative 3.30 times 10 to the power of 4, which would give us, and then we multiply this times 100, and that will give us a percentage error. I forgot to write it down, sorry. So we do, if we put in the calculator, it will give us 0.09 times 10 to the power of 4 divided by 3.30 times 10 to the power of 4. Don't forget the units, PA, and that would give us 2.73%. Okay. So now we have shown that we understand how to use the percentage error through 3 different levels, easy, hard, and medium. And we also know how to calculate for delta H and as well for Q. I hope this was helpful for you guys. Please leave a like and a comment and subscribe. Thank you. I appreciate it. Have a nice evening.